Okay, looks like we're recording. Okay, great. So welcome everyone to the State of Payment Fraud and How to Prevent It webinar. Just a quick introduction about myself. My name is Gabe. I'm here at the customer success team at Fingerprint. I've been here for almost a year where I help customers integrate the API correctly, get the most out of our fingerprinting service and device identification. In my free time, and before I joined Fingerprint, I've been self-taught doing CSS, JavaScript, mainly front-end interface design. So I'd like to start off with just a few numbers, basically why we chose payment fraud as an important topic for this webinar. So let's explore some quick stats. So for the first one, for every $1 lost by e-commerce retailers due to fraud, it costs them about $3.60. So this highlights the compounding effects of chargebacks, where an item that originally is worth about $100 would cost the merchant $360 and chargeback fees, processing fees, and we can share links to sources on these in a follow-up email. The next stat, in 2021 alone, the global e-commerce losses totaled around 20 billion due to forms of payment fraud. And 75% of merchants saw an increase of fraud in 2021 for reasons we'll dive into later in this webinar. So how is payment fraud defined? Essentially, payment fraud can be bucketed into three different categories, and we'll start with phishing attacks. So phishing attacks are a form of payment fraud that is focused on the personal information being obtained in order to carry out fraudulent activity. So for example, obtaining someone's login or credit card credentials through a fake form that really looks like it belongs to a legitimate trusted retailer or payment processor. So like getting an email that looks like it came from PayPal, for example. And these nefarious communication attacks can vary, but mainly occur when fraudsters reach out to victims over text, email, and sometimes today even phone calls. The second is friendly fraud, which doesn't feel so friendly to those affected. This type of fraud occurs when a customer makes an illegitimate refund request, also known as chargeback fraud in the industry. And cardholders can only legitimately dispute these when the charge, when they're a victim of true fraud or when they didn't get a product or service paid for, and when the merchant is unhelpful and unresponsive. And then the last on this list is identity theft. So there are many ways in which identity theft can be carried out, but generally personal information, payment credentials are stolen by a data breach, coming through physical trash and sensitive documents, and other methods. And so as with phishing, the fraudster will attempt to make a purchase with these stolen credentials. And if it goes through, the victim will report the transaction and then resulting in a chargeback. So 4 key signs of payment fraud. The first sign is a noticeable increase in unusual transactions from new accounts or countries and regions at unusual times that historically your business has not seen before. So these might be charges that are much higher than your average order value, or even tiny transactions to test a stolen credit card without the victim even knowing. Also, new countries or regions you've never served might be an indicator. The second is multiple login attempts coming from an IP address across accounts at the same time or within a very small time window. That's another good indicator of fraud. Fraudsters will also try brute force payments, and in some cases, they'll use automated tools, even tools that are used in good faith, like Selenium or Playwright. So repeated failed payments are a strong behavioral indicator of payment fraud. And lastly, an increase in chargebacks might even mean customers are being charged for purchases they haven't made themselves. So that being said, why is payment fraud so difficult to actually tackle and solve? So firstly, customers are accustomed to being able to purchase whatever they want, whenever they want to. So they really expect a seamless checkout experience across their desktop and mobile devices with very low friction. So this need for immediacy has sparked an innovation into the payments ecosystem. And as of now, there's over 60 real-time payment infrastructure companies in the world. So this combined with the fact that over about 3/4 of the world's population has access to instant payments has led to generally an increase in fraud. So with more payments or more players, sorry, in the payment space, the sandbox in which criminals and bad actors can play in has grown tremendously in size. So giving fraudsters more opportunities to phish victims, commit credit card fraud, and so forth. Yeah, so combined with the payment fraud being faster and more prevalent ever due to increase in areas that could be attacked, combined this with the lack of accuracy in device identification, anonymous visitors, even authenticated users, plus the frequency of which attacks can happen, it's just causing a lot of headaches for merchants and e-commerce platforms. So some of the pain points with payment fraud, these problems surfaces themselves as revenue loss due to chargebacks. So chargebacks can quickly add up to a significant portion of money. And even more importantly, too many chargebacks in a short amount of time can result in the loss of ability to process credit card payments for merchants. And exhaustive high friction checkout experiences. So a lot of companies to sort of solve fraud, they'll add additional layers of security like two-factor authentication or CAPTCHA, but this can really bog down and hurt good faith customer checkout experiences. And in some cases, customers will just abandon their cart and abandon the merchant, and that's loss of revenue right there. And yeah, as I mentioned, blocking legitimate customers. So instances of payment fraud can cause companies to really tighten their grip on security and who's eligible to check out. Using those processes like two-step auth, these actions can just lead to really decrease in the quality of user experience and checkout. So now that we've defined payment fraud and its pain points, we can explore the solution. So one of the solutions here is device identification, and that's where Fingerprint Pro comes in. So Fingerprint Pro provides a unique identifier for every visitor to your website, whether they're anonymous, whether they're using VPN or incognito. We generate a stable identifier called Visitor ID. And this is collected behind the scenes anytime someone visits your website or performs a specific action. And the way this works, we have a JavaScript fingerprinting agent that sits in the background, collects a bunch of browser signals using browser APIs, and then sends it off to our servers where we generate the ID. So since malicious attackers might forge this data, our service provides tools for validating these identifiers sent from the client side. So it goes back to just the best practice of not trusting the client. As a result, you can protect your users and your business against various payment frauds with the proposed approaches that we'll dive into. And we have a demo at the very end. We'll explore some of these solutions. And at the same time, without traditional methods like OTP, your good faith customers won't experience any additional friction while performing their payments. So how does Fingerprint help solve payment fraud? So first off, Fingerprint Pro is able to accurately identify visitors that are attempting to conceal their identities, things like VPNs, incognito mode, clearing cookies, clearing web storage, in order to carry out fraudulent activity, coming back as a new person, trying to look like a different person once they've committed fraud. So with Fingerprint, you can flag suspicious returning customers. And basically you're flagging this visitor ID. You're coupling the visitor ID either with a username if they're logged in, if they're anonymous, you still have that consistent identifier. And so by flagging certain customers, trends can be monitored and used to potentially prevent any forms of payment fraud from reoccurring. And lastly, customers make payments through native mobile applications. And Fingerprint doesn't just provide identification for web browsers. We also offer the ability to accurately identify Android and iOS visitors as well if you have native applications. So Fingerprint Pro can be used whether you're supplying the tech to facilitate payments for your customers or accepting payments on behalf of your products and services. So we have customers in both spaces that utilize Fingerprint, whether they're the processor or the storefront. So for e-commerce, Fingerprint Pro can bolster your fraud detection and prevention capabilities, as well as identify anonymous visitors or authenticated users coming to your website. So some of the benefits of using a service like Fingerprint Pro, to name a few that we've seen with our largest customers, flagging users responsible for these fraudulent transactions to prevent fraudulent activity like chargebacks from reoccurring. Whether the bad actor clears their cookies or changes region through a VPN, it won't change the browser identifier. The visit ID is stable over a long period of time. And secondly, when it comes to authorizing payments, speed is everything. And so Fingerprint API's response time is around 200 milliseconds, well below the threshold for payment acceptance or denial. And we have data centers in regions across the globe hosted on AWS, so United States, Europe, and Asia Pacific region. And another benefit is quick implementation. It's very easy to integrate Fingerprint into an existing project. So you can get up and running in days, weeks, instead of months. You can quickly respond to recent fraud attacks. Our API integrates with just a snippet of JavaScript. It's about 10 lines of code, and we're continuously building out integrations for improved dev experience. So you can integrate using vanilla JavaScript, but we also have open source packages for popular frameworks like Next, Svelte, Vue, and we're coming out with new integrations all the time. And then the identification accuracy. So with 99.5% accuracy, you can either enhance your existing fraud solution with more signals. We provide a myriad of data points in our API response that you can plug into your existing models. Or whether your backend is built using Node, Python, Go, you can easily integrate fingerprint data into an existing project. And we also support webhooks out of the box for automatic bulk collection of this identification data. Let's talk a bit about accuracy and why it matters for this use case. So highly accurate and stable visitor IDs for preventing payment fraud are a game changer. We have lots of customers who, by inputting our visitor ID into their data models, immediately see an increase in number of fraud attempts caught, as they have just better insight into patterns of behavior, such as number of failed login attempts or chargebacks caused. So before implementing Fingerprint, customers may have used in-house solutions like cookies or IP-based matching, but fraudsters can easily navigate around these sort of primitive solutions. Another thing to note is that compared to our open source libraries, you'll see in this chart, the Pro offering is significantly more accurate over longer periods of time with less drift, even over 120 days. And the baseline accuracy is also much greater thanks to the server-side analysis that we perform, the proprietary signals that we offer in the Pro offering. And open source compared to Pros is collecting just a very tiny fraction of the number of signals that the browser exposes. Here's a collection of customers that are currently using Fingerprint for fighting fraud. We have people in the BNPL space, as you can see, with Zip. And I'd like to finish this off with a real demo using some payment fraud mocks. So I'd like to say with these demos, they're all open source. We can share in a follow-up email links to the GitHub repository where you can dive in and see how we're handling these use cases. So I'm going to refresh the page, clear my cookies, refresh. Okay, so for this use case, I'm pretending I'm a customer at checkout. I'm going to place an order. Payment went through. This time, my second order, I come back, I'm going to ask for a chargeback. I'm going to place the order again. I can refresh the page. I'll ask for another chargeback. It goes through. Depending on your business logic, you may need to tweak the numbers here. But after more than one, we won't perform the payment. And so the real magic, the aha moment here is that I can clear cookies, I can change Wi-Fi, I come back and the browser will still be identified with that ID. And so it recognizes I'm the same visitor ID. This visitor ID, for example, ABC123 is associated with some chargeback that occurred, and it won't let me process the payment. So let me explore some of the code that we have running this example. We always recommend customers that they perform some sort of server-side validation to prevent fraudsters from sort of getting around fingerprinting. So what does this look like in practice? The low-hanging fruit is checking, does the visitor ID match a specific format? So just using regex. You can also look at our server API. down here. If the visitor ID is spoofed, if it doesn't exist, if the fraudster submitted a fake visitor ID in the request, our API just won't return any data for it because it doesn't exist. We also need to look at the freshness of an identification request, because the public key that you use to actually generate or send the API request is exposed in the front end. Someone could take that public key, try to phish a victim, grab their visitor ID, and then use it. So we need to look for the freshness of this request. And we're doing that right here by looking at the timestamp. Confidence score is another big metric that our customers look at. This is the degree of certainty that the visitor identifier is correct. So low confidence score generally may trigger, in some use cases, another layer of security like two-factor authentication. So for this example, I believe we are using 0.9. So it's a range from 0 to 1. And a few others before I jump over to the payment handling logic. Let's see, so checking confidence score, we also check the IP address. We want to make sure the IP address and the identification, the fingerprint request matches the IP that's coming from your checkout API. If they're different, then the fraudster is trying to do something there. And then checking origins. This is useful for the phishing, for the impersonation. If someone grabs your key and then tries to mimic your website, you'll notice the difference in the origins. And then let's jump over to the payment logic. So here we're doing, for demonstration purposes, we've set the 4242 test card, but we're also checking for, every time we process a payment, we're looking for, was this card stolen? Was it reported stolen? We're checking for card cracking. We're checking for chargebacks, and then we process the payment. And so every payment attempt, whether it's fraudulent or not, is still logged because we need to build up that history of activity with a visitor ID. And yeah, that's basically the logic that we have for this example. Like I said, it's all open source. You can explore this repository and use any of the code however you see fit. So thanks for coming to the webinar, and I'd like to finish this off with some Q&A time. So I'll give a few more minutes for, oh, there we go. So what's the difference between Pro and open source version? Yeah, so Pro is, so I'll start off by saying open source version, free to use, completely open source, but it's a client-side library. So it's performing all the browser signal collection in the client, but also the generation of the identifier, which we call a hash. It's really a hash of all these values like Canvas API, fonts that are installed on the machine, and it's just generating a hash based on all those values. With Pro, though, we perform server-side generation for this visitor ID. So we collect all these browser signals, send them over to the server. API sends back a visitor ID. And then the value proposition here is that the accuracy for Pro is significantly higher, whereas open source is around 60%. Pro is around 99.5 starting out. And then someone, Akos asks, what about mobile devices? They're way less unique than desktop devices, use like cookie connections, the rest generate false positive connections. Yeah, so mobile devices, actually, looking at our data, the accuracy percentage or rate for mobile devices is considerably higher. So things like Android or iOS native, we have, again, the 99.5% accuracy. Okay, it looks like those are all the questions we had. Oh, visitor PII collected. No, so a lot of the information that's collected is it's essentially anonymous. Things like fonts. The most personally identifiable information that we collect is IP address. We have to collect that anyways because they're connecting to our service. Will browser privacy initiatives affect you? That's a good question. We've seen this come up in the past. Our R&D engineers are continuously keeping up with changes in browsers. One example is Brave, the privacy-focused browser. But we've also found in our data that it doesn't really do a good job of preventing fingerprinting. Even when you have all the anti-fingerprinting techniques enabled, we can still accurately identify the browser. Spoofing, if you do, how accurately? That's a good question. So we have some tampering detection in the works. I know recently we published an article about spoofing these values. Some browsers like Brave use this approach where they want to mix all the signals together so you generate a new identifier every time. But one of the techniques that we do is we can test these values. If we notice that the browser every single time has a new like canvas hash, for example, or another signal that we know some spoofing is going on. Would device language be captured in addition to country location? Yes, we do look at language settings as well as time zones. How to fight with such, so someone's asking if IP address changes, fingerprint hash also changes. Yeah, so IP-less matching is something our R&D engineers are working on. It's one of the greatest areas of improvement for our service. And then another question, do ad blockers affect fingerprinting? They do. If you're using Fingerprint Pro in itself right out of the box, some of these ad blockers will block the script from loading. They'll also block the post request from going through. So the way we navigate around that is we offer a feature called subdomain integration. You'll plug in a custom subdomain that matches your origin, and that way ad blockers won't block the request. As far as the source of downloading the JavaScript agent, we have a Cloudflare integration where you can actually use Cloudflare workers to download the JavaScript. And again, ad blockers will ignore that because it's coming from your domain. So in short, yeah, ad blockers won't affect the fingerprinting. Okay, I think those are all the questions we had. I'll leave another minute for questions. Okay, looks like there's no more questions, so we'll be wrapping this up. As a reminder, we'll be emailing a recording of this webinar to everyone who attended. So yeah, thanks for coming, and we'll stop it here.